Well, thank you. My name's Jeff Raberding. I'm one of the forecasters at the office. Probably many of you know me. The ones that don't, I've been here for about 6, 7 years. I've been in the Weather Service going on 29 years. So been around the country, Wisconsin, Texas, Kansas, and Missouri are the states that I have served with the Weather Service in. So I'm also the winter weather focal point at the office, as well as the aviation focal point. So I'll be taking you through this. Like I said, this is, like Steve said, it's our last webinar, kind of preseason webinar coming up. I know it's kind of weird to talk about winter weather today when it's so mild, but we know it's right around the corner, and here in Missouri, anything can change. So our presentation today is going to talk about, it's going to be really in about 4 parts. We're going to talk about the Climate Prediction Center's winter weather outlook. And then we're going to look at some of the winter services and messaging from the National Weather Service that we do, both from a local office standpoint as well as from some of the national offices. Specifically, we're going to get into the watch warning advisory. Those have been around for eons with the Weather Service. We're going to talk a little bit about the situation report, probability of snow, the graphics that we put out, and probabilistic messaging and how that's going to look. One of the new, and probability of snow has been around for about 2 or 3 years. When we get to the winter weather severity index, this is going to be one I think that's going to be kind of, I don't know if it's a game changer, but it's really going to focus on impacts. And that's what a lot of our partners are looking at. What kind of impact are you going to have in terms of a particular winter system? And we'll show you some of that and where we can find that. The graphical hazardous weather outlook, many of you are familiar with, we'll look at that. The area forecast discussion, this is really that gets behind what the forecaster's thinking, and then we're going to get into NWSChat and the use of that and kind of what we can expect on that. The next thing is going to be kind of getting into the weeds a little bit. We're going to go into the forecasting, how we as meteorologists forecast ice and snow, and then finally we're going to look at snow squalls, what they are, and we're going to actually look at a case study that occurred in Iowa last year. Gives you kind of an idea. And again, snow squalls are new in the Weather Service. Snow Squall Warnings are new in the Weather Service here over the past year. Should be hopefully a rare event around here, but nonetheless, it's something that we have to be prepared for. So let's look at the winter outlook. This was made on October 15th from the Climate Prediction Center. That's what CPC stands for. And this is for the months of December, January, and February. And you probably heard of La Nina, El Nina, neutral conditions. Well, we're going into a La Nina, probably a moderate condition, and this is expected into the spring of 2021. And by doing this, we can kind of see from a seasonal standpoint when we have these conditions of what is typically expected. But obviously, as you know, weather doesn't always play by the rules, so things do vary. So take it with I wouldn't say a grain of salt, but it is a seasonal outlook. Basically, what La Nina is it's looking at the sea surface temperatures in the equatorial Pacific. And you see here the warmer than normal and cooler than normal areas. And what this is research has indicated there is a connection with sea surface temperatures and things that go on down in the equatorial regions for weather patterns in general across North America and South America. And then generally we can start pinpointing whether or not it's going to be drier than normal, wetter, cooler, or things like that. And it really affects North America and South America a lot. And you're hearing more and more, probably the last 10 years, of what these, as we get more data, more research into it, some of those connections that we have for our weather patterns. But it's really a general weather pattern. It's not a specific forecast per se as to we can get general trends off those for a winter or a month or so. So what a La Nina is, the general pattern, the expected weather pattern or average or however you want to say it, is similar to what this map shows. And the blue arrow in the center basically is the storm track, if you will. It's the jet stream. It's the main storm track. So pretty much anything north of that is where it's going to be colder, maybe a little wetter than normal, and to the south of that is going to be drier and warmer than normal. And notice that average jet stream, where does it cut? Right through Missouri. So we'll have to see what that means for our winter in terms of a climatological perspective there. So when we start looking at these outlooks, and many of you have probably looked at them, we talk about a pie sheet and how the pie is divided up. And we're going to look at, in this one, I think Steve made this one up, so I think his favorite or must be peach pie, cherry pie, and blueberry pie. But we're going to look at how that's chopped up, and we're going to look at that, think of it in terms of, and I'm not a baker, I don't know if you could make a third of a cherry pie and a third of a peach and a third of a cherry. Maybe you can, I don't know. But that's kind of what we're going to do is divvy that up and look at what as far as normal. So think of it as this way, and this is the way the outlooks are kind of centered. If it's equally divided up between the peach, the cherry, and the blueberry, it's basically 33%, each one's 33% of the pie. So it's equal chances of being any of that, if that makes sense. If you just blindly grab it, you've got a 33% chance of getting a slice of apple or peach pie or whatever type of pie it is versus the other one. And that's really what the Climate Prediction Center outlooks are very much like, as they go by that. But think of it as colder than normal, warmer than normal, or near normal, or equal chances of being above or below. So if you have a situation like this, where you have 52% of it is cherry pie, you have a greater chance of, when you blindly take that piece of pie out of that you're going to get a cherry pie, a slice of cherry pie. And that would be the same thing with the climate. If you've got a 52% chance of being normal, you still have a 15% chance, or above normal, you still have a 15% chance of being below normal and a 33% chance of being near normal, if that makes sense. Any questions on that? Some of it, I think it'll make more sense as we get into some of this other maps. These maps you've probably seen as well. Again, you can see that 33% line that goes right through Missouri. Surprise, surprise, huh? It seems like we're always in there. But on the left, you see the 3-month temperature outlook. And anything in the orange is skewed towards the above normal. So you see those percentage, 33%, and that's the line that does the equal chances. So that white area is that equal pie. And as you get down to the southern United States, you get more into the warmer, the chances of above normal temperatures. Now, with that being said, this is an average over a 3-month period. It doesn't mean that you're not going to have very cold outbreaks or very warm outbreaks. It means when you average the temperatures over December, January, and February, take the high and low each day, average that out, and if it's above normal, then it's above normal. If it's below normal, it's below normal. So it can be 0.2 of a degree below normal, and it's considered below normal. So it doesn't mean that you're not going to get extreme weather conditions or extreme cold by saying that. Perfect example is what's happened over the last month, where we had really cold October weather well below normal, and now we're up into the 70s and 80s. So those are the typical swings that we're still going to get. We're still here in Missouri, in the center of the country. On the right is the precipitation probabilities, and again, it's skewed. Again, remember that jet stream that I talked about, the storm track on that first slide, where it kind of cut through Missouri. That you kind of see the dividing line between the below normal precip and the above normal precip is kind of on the north side of that, and that's what we're seeing. And here we're kind of in the equal chances. Now this is from a broad scale. This is from a scale of the United States. Other Climate Prediction Center products that they have on their page, we just talked about the seasonal ones. They also go down to monthly. So as the month progresses, you can look at just what the December or January or February month is. They even get down to 8 to 14 days, 6 to 10 days. So you got general trends of above or below or equal chances of above and below normal. So there's a whole suite of products they have that goes, again, from the seasonal down into the a couple of days. Usually the 3 to 7, the 0 to 48 hours is where we come into play rather than the Climate Prediction Center. But all of this is kind of a funneling approach from the seasonal right down to the few days out. Here last week, or a couple of weeks ago, or last month, I guess it was, we were in a drought. They have drought information on there as well. I don't know what the date this one was. Can't see the date on December. Yeah, valid September 17th to December 31st. And this is an outlook for what they expect drought conditions going on. And these are changed periodically to update as rainfall does occur across the area. And here's the, again, you can get a half month, month and a half, 2.5 month, 3 month thing, outlooks of precipitation, temperatures, and things like that. So again, a lot of information on their page. There's a page, it's cpc.nsap.noaa.gov, or just do a Google search or whatever your search engine is to Climate Prediction Center, and you'll find a whole lot of information, and a lot of information on there that explains these things probably better than we can get into, or more detail than we can get to on this webinar. Okay, so now let's pare that down. We've got the big look here of the whole United States. Now we've done some local studies here to see, and the interesting thing on the local studies is this is a freezing rain trend. Now this only goes out to about 2010, and it looks as though that expected conditions for the winter are for a below normal freezing rain. There's a strong signal for that. Kind of makes sense if you're kind of tilted towards the warmer than normal type situation. As far as rainfall, this is just generally rainfall. There's not a strong signal for anything near normal. It's either below or above normal. So, gosh, what do you know? Feast or famine for the Ozarks and southeast Kansas. So these are based on studies that go through from about 1948 to 49 through 2009-10. So it doesn't really take into account about the last 10 years of data that we have, but I think the trends are probably pretty similar to that. Also, what about snowfall? I need to get rid of this so I can see. What about snowfall? Well, there's a strong signal, as you can see here, of above normal snow, a 66.7% chance of having above normal snow in a La Nina winter. What's funny is, here's some information on the snow that we have. We don't get a ton of snow here in the Ozarks, and I've been back here since 2014, and since that time we have not had any greater than 6-inch snowfalls here in Springfield. There has been some isolated areas to the south and the north, excuse me, we get some of those banded snow situations where you get 5 or 6 or 7 inches in a localized area. I say this every year on my preseason presentation, is that we're due for some big snows. Now, I've said this enough. I shouldn't probably say it. Maybe it's good I say it, because it seems like every time I say it, we don't get it. So I guess if for those snow lovers, I'm jinxing you. For those that don't, maybe I shouldn't say it, and we will. But it has been quite a while since we've had a very large, what we call synoptic snow, widespread heavy snow, where you're getting 6 to 12 inches or something like that. I know last year we had some, or a couple of years ago, we had some snows up there in central Missouri that did get 6, 7, 8 inches of snow. So, but here across the South, again, we haven't had a ton. The percent of years with greater than 6 inches of snow, this is from 1951 through 2004. So some of the data is somewhat older, but it's a 56% chance of less than 6. So 56 out of 100 winters, you're going to have less than 6 inches of snow. So that's pretty much, I think, what we've seen locally. Again, like I said, we're due. So what about blizzards? Well, on the left is some events. These are not events necessarily that occurred here in southeast Kansas or the Missouri Ozarks. They're events that occurred in and near the area. So they do happen. But one of the things we want to point out is really, what is a blizzard? A blizzard really is defined as really 2 things: visibility, frequently below a quarter mile, and falling or blowing snow, and that has to persist for at least 3 hours, and wind speeds of at least 35 miles per hour. Now, of interest, and I've always thought this was interesting, and a lot of people that I talk to, is it says nothing about snow amounts, the definition. So you can have 1 inch of snow and still have a blizzard, because all you need is the visibility to drop below a quarter mile in 3 hours and wind speeds of 35 miles per hour. What was funny is, just kind of a story on this, is I had a coworker who is from Williston, North Dakota. And as a kid, he said he remembers the worst blizzard he could ever imagine. So when he got in the Weather Service, he looked it up, and he found out that they only had like 2 inches of snow, but he said drifts were so high that they were over fences. And he said it seemed like a ton more snow, but they had winds of 60 miles per hour with that. So it doesn't take a lot to really reduce the visibility or create a lot of havoc there. Although not required, most involve some sort of falling temperatures associated with the strong winds, and some other terms that maybe are more familiar with people. A ground blizzard, where you just have, it's more of a low level, it's not lifted real high, or whiteout conditions, which involve blowing snow with little or no new snow. Now, sometimes you get out these brief white, especially here in the Ozarks. If we do get a bigger snow and you can get up on the ridge tops and you get some open areas there, you're likely to see some of those whiteout. If you have high winds and you've got fresh snow on the ground, you could see some localized whiteout conditions there. I'm sure people have driven around the Ozarks, know these areas that are open. As far as where the most likely, I mean, obviously blizzards are common across the plains where it's wide open, miles of nothing except maybe a fence or a telephone pole. Here in our area, probably the most likely area to see a full-fledged blizzard would be up over the Osage Plains, where it's a bit open, over in southeast Kansas, where there's more open areas than there are here in the Ozarks, because the hills and the trees seem to kind of dampen that down a little bit. Okay, well, it's Missouri, so in most places that I've been, when you talk about winter weather, you talk about snow and ice and all that, but here we've got to throw in tornadoes. And here's some of the tracks that we've seen during what we call the cool season areas. And one of the reasons why we bring this up is because of the ENSO phase that we're in, the La Nina ENSO. And if you look in there on the far left, you see La Nina. Now these are tornado outbreaks, and a tornado outbreak is classified as any 24-hour event that had 3 or more confirmed tornadoes. And lo and behold, you look at the winter, it's above in the blue bar there, and you look as you go into the spring, up to 5 outbreaks over that period of time. So that's a secondary thing that we have to look at. Branson got hit, was it the Sleet day, I believe it was, a few years ago. And so that was in late February. And so that's just something to keep in mind. We're here in Missouri. We have to kind of look out for anything during the season. You know, when I was in Wisconsin, we could shut down the severe weather about November, and all we'd have to concentrate on was snow and ice and cold for the next 6 months, and then we could ramp up. But here, it's really not the case. You ramp up, you keep the tornadoes and severe weather going throughout the year, and then you throw the ice and snow in for a few months of the year as well. So we're definitely in that battleground area here in the central United States. Obviously, flooding. This is a MoDOT map from the December 2015 event. If everybody remembers that, we had 10-11 inches of rain. That was probably my first big event here. And I was like, man, it rains a lot here, and this is around Christmas, right after Christmas. In fact, I had a leaky roof and people had to come out and repair it in the middle of the rain as it was coming through my ceiling. So, but we do get that along with the severe weather. We can have a number of heavy rain events and flooding events. And I know Megan we had a presentation on that, a webinar a few weeks ago on the flooding. So hopefully everybody got a chance to view that. Okay, I'm going to pause a little bit right here, see if Steve wants to add anything, or if we have any questions on that part before we head into the next section.
Jeff, I think you're doing a terrific job. I don't have any questions that have come in up at this point in time. You know, that La Nina thing is a very well studied phenomena. Obviously, you think about something that's occurring in the South Pacific, and why is it going to affect our weather here? Well, there is a direct correlation between the water and the air. And in the case of that jet stream, predominantly being northwest to southeast, it is a firm control of our weather pattern. But as Jeff said, it does not mean that an individual storm will not form and cause that jet stream to move a little bit. And that's when we do get not only those heavy snowfall events, but also the potential for tornadoes and flooding. So very pleased, Jeff, that you covered all that. I'll go back to blizzards just for a second. One that was not noted on the list there was one that Ted Martin had brought up, 1980 or so, in the Kansas City metropolitan area. He says major snowstorm, drifting snow, with wind, huge drifts. So it just goes to show you, here in the Ozarks, here in Missouri, we indeed can even get blizzards. So with that said, no additional questions yet, Jeff. Go right back to you.
All right. Well, this next section, we're going to go over some National Weather Service services and messaging strategies. Some of it is the products that we'll go over, some that you're pretty familiar with. The basics, the watch, warning, advisory, these have been around with the Weather Service for eons. And we'll just briefly go over it. Basically, a watch is issued when the risk of a hazardous weather event is significant. So we're expecting significant impacts. Usually it's in the 12 to 48 hour time frame, maybe go out as far as 60 hours, but occurrence, location, severity, and our timing are uncertain. Basically, and this is kind of it's not a set in stone, but it's up to the individual forecaster or forecasters to determine what their confidence level is. And generally, we're looking at, say, a 50 to 80% confidence level in there for a watch that's going to happen, and we know something significant is going to go. As you get into the warning phase of it, this is when we expect significant weather conditions to occur or are imminent. These are usually, and we have specific criteria, but they can also include impacts of what. So not everything is the same. It could be a straight 6-inch or greater snowfall, but it could be lesser snowfall if you start adding wind and sleet and freezing rain. So there's a little wiggle room there because it is kind of based a little bit on impact as well as just how much occurs. So that's a warning. And then the advisory, that's issued for, again, an event that is occurring or imminent or has a high probability of occurrence, but for less serious conditions. So it's usually those slight freezing rain events or freezing drizzle events or a 1 or 2 inch snowfall or something like that with little wind that may not have an effect. Now, oftentimes what you see is you'll have this big blanket watch out because the watch is covering a larger area. There's a lot of uncertainty there still. We've got enough certainty to say something's going to happen, but we can't pinpoint exactly where it's going to be. So we issue this watch. And for example, let's say we may issue a watch for all of our 38 counties in our county warning area, which is southeast Kansas and southern Missouri. As we get into that, we can start, as we get closer to the timing of the event, we can start to pare down that and say, okay, now we need a warning across the north. That's where the most significant weather is, but we're going to put an advisory out to the south or nothing to the south or things like that. So that's kind of how that works. It's kind of a forecast funnel that we go into. Some of the other products that we use, a situation report. You're probably familiar with this. It really starts with a broad overview of expected hazards with additional pages provided for individual hazards. For example, in this situation, we have one where it says winter weather is expected Tuesday and Wednesday, and it gives the expected snowfall amount. And then the next page gives you a range, maybe a snowfall or where the highest impact is going to be. And then, of course, we're in Missouri, so it's not just one precipitation type, it's going to be multiple. Excuse me. So here we have the heavy rain and flooding that we throw in. So in this case, there's both winter weather and heavy rain and flooding going on. And it explains all those both graphically and text. And so these are emailed out to our partners. So I think everybody on this call probably is on that email list. We are also doing, and of course, 2020 has been a different year. We have a lot of COVID sites, and so we're doing a tradition or a daily sit report in the morning, and that's sent out to only those who really want it, who are dealing with the COVID testing sites. Normally, then, if there's a significant event, we will go ahead and send it to our complete partner list. So you'll get that. It's a tap on the shoulder to say, hey, something's coming. Here's what we know. And then we'll gives you basically a tap on the shoulder to say, hey, you need to start watching this. ProbSnow, this has become into the Weather Service in the last 2-3 years. Prior to about, I would guess 5 years ago, I'm guessing on that, don't hold me to it. We did what we call deterministic forecasting. We basically hit a button and the product went out and it would say we're going to get 5 to 7 inches of snow or whatever it is. Now we're getting more in the last few years into probabilistic type forecasting. It's more information for the users to use. So this ProbSnow is run off our database. And basically it gives the expected, if you look at that one, the part on the left there, it gives what the expected official snowfall forecast is. Now this one, this example wasn't good because I grabbed it in early October, I think it was, so we didn't have anything. But normally it would have amounts in there. So it has the expected snowfall, what we're expecting. That would be example, the old type deterministic forecast. But then we also get the high end and low end amounts. So that serves, if you look on the upper right, we have a football goalpost. Those serve as the goalposts of the high end amount and low end amount. And we'll get into some of the problems with doing this and how we message that, because there are gradients that we have to deal with of, and we'll see that here in a little bit. I won't get too much into that now. But it also gives on this page, and it can be found at weather.gov/SGF winter. You go to there, and you can also pull up a probabilities of snow greater than 1/10 of an inch, 1 inch, 2 inch, 6 inches, or 8 inches. So that also gives you the range. And even more, I don't know if we have any school people on here, school superintendents or anything, but safety officers, but you can go to a pull down menu and you can select the county. And in this case, we've got, I can't remember what county, but we've got, and you'll see a different, whatever county it is, you'll see a bunch of cities in there. And then you'll get a tabular where you can see the low end, and this is the one on the far right. Low end, expected snowfall, and the high end. So it gives you those goalposts, what we're expecting, which is, say, the most likely outcome, but the range is in there. And then it gives you the probabilities. Now, these areas, these cities are actually set, the latitude and longitude that we could set were set on the local high schools, because the school districts can use these then for planning purposes as well. So that's an excellent way to see what is expected and what the range of expectations are in terms of that. So this goes into more probabilistic messaging. How do we as meteorologists message to the public? You got to remember, we could have the most perfect forecast, and if it doesn't reach the public and the public doesn't understand it, it becomes a worthless forecast. So we really have to hammer in on, okay, we've got this information. Now we need to share it in a usable way for partners, the public, whoever it is that's using that. We have to do that so that they can make decisions and make good decisions on that. So again, we do this forecast confidence, long range, medium range. So here's the long range. Our confidence level is less than 30%. On this particular graphic, you see the current location of this storm system is well out in the Pacific, south of the Aleutian Islands. And of course, probably by this time, you're probably getting Facebook posts from different things of huge storm coming into Midwest, and they're going to be grabbing maybe one model that's showing 18 inches of snow in Springfield. And so that's going all over, and you're getting calls. Well, here's the problem. Look how far that's got to go. That's got to go across half the Pacific Ocean, come inland, across the western, across the mountains, out in the plains. And then based on that, we're supposed to tell you how much snow you're going to get on I-44 between mile marker 38 and 42, or in your backyard or in your schoolyard. So you can't do that. You can see what happens is we know something's coming in. So we can tell you what we know. We can tell you what we don't know, and we can tell you what you should do. For example, this path, if you look at the storm by Wednesday, it's over the Four Corners region, and then the path could be up towards Sioux Falls. That puts us in the warm sector. We could have showers, thunderstorms, flooding, tornadoes. It could go towards Kansas City. That pushes us probably still in the warm sector, but if it goes further to the south in Arkansas, now we've got the winter mess, and Sioux Falls is just cold and nothing going on. So there's a wide range of things. The only thing that we know is a significant storm is going to affect somewhere from, say, Arkansas or Louisiana all the way up into South Dakota. So as you get into the medium range, now our confidence is 30 to say 50%. Now we can start honing in not so much on exact amounts, but the probabilities of where the impact is going to be. And this is really what, I mean, as meteorologists, we talk about we tend to think about amounts, and that as our partners, whether it's MoDOT, whether it's emergency manager, you're thinking impact. You're thinking what's it going to do? How much problem is it going to cause? And so again, we can't be specific this far out. Again, our confidence level, this is from a forecaster or a group of forecasters, is generally in that 30 to 50% range. Again, we're kind of in the outlook area. We're not even in a watch phase yet. Okay, this is just below the watch phase. But you can see here, we can target certain areas of, say, these particular ones were out in South Dakota. There's a potential for at least 6 inches of snow out in central South Dakota, but as you move to the east, the probabilities go down. And the same thing here on the right. It's a different storm, excuse me, but you can see that the impacts are greater to the northwest than they are to the southwest or northeast to the southwest. Keep in mind here that if your jurisdiction or your area of responsibility lies in that gradient area, say you're Sioux Falls and you cover northwest Iowa, and maybe you cover up towards that, I think it's Madison, South Dakota, guess what? You're on that gradient. Keep aware of what might be going on there, okay? Now we come, remember I said a watch is generally in that 50 to 80% confidence level. So we're getting close. Watches are probably going to be coming out. Again, we're going to start maybe changing our message somewhat in terms of getting a little bit more specific. We're still going to put those potentials out for at least 6 inches or 2 inches or whatever it is. We're going to talk about travel impact risk, and we're still going to put that forecast uncertainty in there. And then we might pull in these probability of snow totals that was on our probability page that I showed earlier, and say, well, there's a probability of 2 inches of snow is 100%. Probability of 6 inches of snow is 50%. It's that goalpost, and we're starting to the amounts are starting to hone into kind of a range there. The range is still quite good, but we're getting that goalpost set up for you. And this is again in the watch phase. And again, our confidence level, if we're on the 50% side in this time frame, maybe we're still a bit more not as specific as we're closer to that 80%. Maybe we're adding a little bit more information that we know about. And then in this case here, again, I talk about the gradient, that gradient area. If you're in that jurisdiction, this is something that you need to be very aware of, because look at these snowfall amounts. If your area covers, say, Sioux Falls and goes down into northwest Iowa and goes up into, say, Huron, let's say that's your area that you're covered, you're going anywhere from 22 snow in Huron and very little in northwest Iowa. Now, we've had situations like this, not that drastic, but we've had situations last year in February, I think it was February 5th, in which we had some snow to the northwest of Springfield at about 5 to 6 inches. And then Springfield, we were expecting that gradient. Springfield was on the gradient, excuse me, and did not get very much. So keep in mind, this is where those goalposts are very, very important. Your high end, low end range. Are you on that big spread? And you know, I guess you have to keep that in mind in terms of making decisions there. So again, the warning phase comes in, it kicks in at about 80% confidence. And this is really the confidence that the forecaster or forecasters have in terms of doing it. And when we make those decisions, we don't make them alone. We make them with our colleagues, not only within the office, but we make them with the colleagues, say at St. Louis, Little Rock, Kansas City, Wichita, and things like that. So it's kind of a group effort there. Okay. So we talked a little bit about impacts. We'll go back to our products. This is another one that's fairly new. It's called the Winter Weather Severity Index, and it's a graphical depiction of impact, really. And this is impact based. It has impacts from snow amount, snow load, ice accumulation, flash freeze, blowing snow, and ground blizzard. Now the impact goes out 3 days. They got a day 1, day 2, day 3. You can see this from a CONUS view. You could also zoom into closer in like I have here. And it's found, there's the URL link that you can get to it. One of the things that what's nice about this is it takes our forecast from what we've got in our database and uses it for that information, but it also takes in climate normals. For example, 2 inches of snow on Marquette does not have much impact at all in Marquette, Michigan. 2 inches of snowfall in Springfield has a much larger impact. And if you take that 2 inches of snowfall in New Orleans, it's got a huge impact. So it does take in that. You may only have a 2-inch snow and you're going to get these major impacts or extreme impacts down in Louisiana, say, for example, where in Marquette, it wouldn't even show up blue or nothing like that. So these are very, very, I think, very good for our partners to look at. And we can start posting these also in weather stories and things like this, but it does highlight the areas. In fact, you can see here the different impacts that we have from this particular one. This was October 26th. That was, I believe that was the day of the ice storm that hit Oklahoma into southern Kansas. So you can see the area where they expected, and indeed they did get that as well. Okay, our graphical hazardous weather outlook. I'm pretty familiar with this. This has been around a way. There is a text version of it, but also the graphical. The one that I grabbed here was from October 29th, so it's highlighting the frost and freeze risk there. And you can see there's a bunch of little buttons there, radio buttons or whatever, that you can look at, or skittles, I guess they're called. And you can see out day 1, Friday, Saturday, Sunday, Monday. So you can just click on those, and it will give you a map like you see on the left, and it tells you where that threat area is. And the risk categories, if you want to know that, is at the bottom of each one of those. And basically, this is the one, I believe, for snow or the snow and ice, and it talks about, you know, what significant means. Plan for hazardous conditions, avoid travel if possible. So this is found on our internet page, weather.gov, CRH, and then you can go to that, or there's a just navigate around. A lot of these websites we're given, we can give you, if you email us, we can give you the exact ones. I would highly recommend that you go through some of these and kind of peruse around when you have some spare time to get used to it, maybe bookmark some of the sections so that it's easy to get to once you get into the active winter weather. The other thing is the area forecast discussion. Now, this is a non-technical discussion, excuse me here, forecasters thinking, and it's basically the forecaster writing down what he thinks is going to happen. It also gives the different caveats of what may or may not happen. The reason that I bring this up partly is sometimes we use terms in there, specifically since this is geared towards winter weather. We talk about, for example, the warm nose or cloud ice. And we've got a section here at the end that will get into why those are important. So when you're reading this, a lot of that information will be answered in some of the other sections of this presentation here. For an example of a real-time example of what's going on tomorrow, we have as far as I know, when I got on here, we had a marginal risk late tonight or tomorrow for severe weather. And that marginal risk is really dependent upon how much instability is going on. And so in the area forecast discussion, if you've been reading it the last couple of days, you'll see that that is the one, if you will, fly in the ointment that could nullify any type of things. Or if we get higher, then maybe we'd have a higher degree of things. So that's the variable in all this for tomorrow. And so that's what you'll pick up from the area forecast discussion. NWSChat, you must have an account for this. I assume probably everybody here has. Excuse me, let me grab some water here. My throat's going. You must have an account to use this. Like I said, everybody has, and you can interact with us as forecasters or partners. You can see this one. I screen captured this a couple of days ago or a week ago or something like that. And one of the things that we do, you can interact with us. We will post things in there. We'll post real-time information, whether it's severe weather, reports that we're getting, things automatically report. You see here the hazardous weather outlook was somebody issued that, it popped up, frost advisory, things like that. The other thing that we've been doing at least twice a day, sometimes in active weather, it might be more than that, is we will put in there a forecaster thought of the day or message of the day. What are we thinking? What is the message that we're trying to get across for everybody to take? And it's in plain language. So, and I think everybody likes that. I know other offices are doing it, so it has become standard practice. But it's really a free flow of information during hazard events or even leading up to hazard events where you can ask specific questions to us and we can give you specific reports and things like that. And it's been very, very useful. You can see here I have a lot of rooms open at the top because each office has a chat room. So I've got, this is my personal one or my work one where I've got the Pleasant Hill office and St. Louis, Paducah, Little Rock. So I can go into there and see what's going on in theirs as well. So it can get pretty busy. You can see all of the, and this is our chat room, SGF chat, and you can see there all of the number of people that were in on that particular day, quite a few there. So it's been very, very helpful for us, and I think for our partners as well. Okay, I am going to stop here and see if there's any questions or comments or anything from Steve, and then we'll go on to the next one.
Okay, Jeff, thank you. I do not have any questions, though I do want to draw the audience's attention, especially the school districts. We've got some folks here from Hartville, Liberal, Lebanon, and Fair Play, and we know that making decisions on school is a difficult one, and we are hoping to get your insights to that probability of snow and the probabilistic messaging in particular as it relates to your decision making. So if you have any initial insights on what you heard today from Jeff, please let me know via the question box. And as we go further into the presentation, especially when it comes to the Snow Squall section, I would love to encourage Darren and Bethany from MoDOT for their insights as well. So at this point in time, Jeff, no questions.
All right. Okay, we got 2 more parts left. They're not real long. This one, I will say, kind of gets into the weeds. So it's not quite a geek fest for us meteorologists, but it really kind of goes in. I wanted to put this in to show how meteorologists go about forecasting winter weather and some of the ingredients that goes in, some of the things that we're looking at, maybe some of the terminology that you might be reading, for example, in the area forecast discussion that I talked about earlier. So sometimes literally we feel like this, 1 inch to 2 feet plus snow unless it rains, maybe. Sometimes that's kind of the way we feel, although we're trying to pin it down, but you know, it is Missouri. So it's rough. Okay, so here is a schematic of winter precipitation types. And you got to remember for winter precipitation, one of the, you know, we're forecasting what's happening in your backyard at the ground, basically. However, what happens in your backyard at the ground is going to depend on what the atmosphere is doing above you at different levels. And notice here that we have this, what we call a warm nose, that brown area. This is warmer air above 32 degrees coming in. And notice to the left, it's very deep. As you get to the right, it's very shallow. Notice that you go from cold rain to a snow. Now, if you want to put this scenario into a geographic area, think about that left part, okay, down there below the warmer air above 32, okay? Think of that as being Branson, okay? And in the middle of there, think of that on the edge of this snow and rain, think of that as being Springfield, and then over to the far right, Camdenton, Missouri, okay? This is pretty typical for what we get here in Missouri. So we're trying to dissect everything from the ground up and determine what's going to happen and how what's going to occur, okay? So what we're going to do is, if you think about it, we're going to trace what happens to a snowflake or raindrop as it forms in the cloud above and follow it down to the surface and how it's going to change phase. Is it going to change phase or not? So we call that the top-down approach. So we basically start at the top or in the cloud layer where the precipitation and moisture is, okay? And we look at that snowflake and raindrop or whatever it is. First, we try to assess whether or not what's there. And then we trace that down as it falls and what type of air it's going to encapsulate. So we're going to ask ourselves, will a cloud droplet or ice crystal form? That's vitally important. What will happen to that ice crystal or droplet as they ascend toward the ground? And basically, what type of precipitation will occur at the surface? And a part of that's going to depend on the surface temperature. So let's look at some things. And don't worry about this. Don't worry about the microphysics. The whole thing on this is clouds or water droplets have to have something to cling to in order to form. That's how droplets form. So they're called cloud condensation nuclei, and they're usually like clays or volcanic ash or whatever. Here in this part of the country, it's usually clay. Okay, those are always in the atmosphere. They're dispersed unequally. We can't measure those, but we can infer certain things by saying, okay, normally it's clay. And notice each one of these have a temperature difference. Some of them are activated, meaning that they will form a droplet or an ice crystal at 4 degrees, -8 degrees, things like that. That's all you need to know about this. This one is it's a bit more interesting. One of the things to note, and I'll summarize this in one thing, you have to have ice in the clouds to get any type of frozen, not freezing, but frozen precipitation at the surface. Sleet or snow, you have to have ice in the cloud. If you don't have ice in the cloud, you will have some sort of liquid hitting the ground, and then it's going to depend on the surface temperature, whether it's going to freeze on contact or not freeze on contact. Okay, that threshold in the cloud layer of ice or no ice, which you'll see in our area forecast discussion, is -10 to -20 degrees Celsius. And notice here that if you had a cloud temperature of approximately -10, you have a 70% chance of ice in the cloud. By -20, you have ice in the cloud. Okay. Anything warmer than that, 0, -4, -5, -6, you have supercooled water droplets. Okay, they're not ice. And again, the big thing is when you read our area forecast discussion, we talk about ice or no ice. It's if there's no ice, you are only going to get drizzle, freezing drizzle, rain, or freezing rain. That's it. If there's ice, then you can get pretty much everything else depending on what that droplet goes down through. So let's look at some soundings. This is why we do the balloons. Let's look at some soundings for typical snow, sleet, and freezing rain. So on this particular one, the red line is the temperature. The blue line is the dew point. So the closer those two are together, the higher the moisture content, the higher the relative humidity. Those lines that are going diagonal, this is 0, -10, those are the temperature lines. And you see I've highlighted here anything above 0, so warmer than freezing is in red, below is in just non-colored there. So what we do is we start out at the top. Where's the cloud there? We kind of look in that -10 to -20 degree range. Well, they're fairly close together there, so we can assume that those droplets are frozen, that there's ice crystals in there. So now we want to trace, okay, what's going to happen as that ice crystal falls? Well, if you follow the red line, the atmosphere all the way from the cloud layer to the bottom is totally below freezing. It's never going to melt. You're going to get snow at the surface. However, the question for you is, if there's no ice in that cloud, so in other words, if the red and the blue line between that -10 and -20 line diverge sharply where it's very dry, what are you going to get? You're going to get either freezing rain or freezing drizzle, because on this particular sounding, you see at the surface, the temperature is right at that freezing. So if it's 31 degrees, you've got freezing rain or freezing drizzle. At 32 degrees, 33 degrees, you've got rain or drizzle, okay? So that's a pretty straightforward. Now we do the same thing with the sleet sounding, but let's add that warm nose. Remember that warm nose, and remember on that thing we had the warm nose expanded or was deeper at one spot. Well, we can measure that on a sounding, and this is why we release the balloons. Now remember, we only have a balloon here that we release a balloon here in Springfield. The next closest one is Oklahoma City, Little Rock, and I can't remember what's up north, Des Moines, I believe. So we don't have a lot of these. So things can change drastically between here and Branson or here and Rolla. In this case, we start in that -10 to -20, and we notice, yeah, the lines are pretty close together. So yeah, we've got ice crystals there. So what's going to happen? Well, those ice crystals are going to fall, and look, and lo and behold, there's a nose of warm air above the ground, and it warms well above freezing, 5 or 6 degrees above freezing. Well, we know from studies that anything really above 3 degrees, it's going to completely melt. It's going to completely melt that. Then it's going to fall back down, and guess what? It goes back below freezing. Oh gosh, now what are we going to do? Well, now it depends on how much below freezing it is and how deep that below freezing layer is. And in this case, it's cold enough, excuse me, and deep enough to completely freeze it, but not into snowflake. It's going to be an ice pellet or a sleet sounding. Okay. And again, if there's no ice in the clouds, I go back there, if there's no ice in that cloud, that those lines at 10 to 20 diverge, you're still going to get freezing rain or drizzle or whatever it is, depending. And in this case, it'd be freezing rain or freezing drizzle because the surface temperature is well below 0. Okay, now we're moving down, maybe down towards Branson. Okay, that thicker area where I said, now look at this, huge above freezing layer there, above this, right above the surface. But we look in that -10 to -20 degree range, and again we have saturation there. We have the lines close together, high relative humidity, so we know we have ice in there. That ice falls as a snowflake, but it encounters this really, really warm layer, and it's going to completely melt. Okay, that happened very similar on the sleet sounding too. But notice the difference now. Now it falls, but it falls below freezing, but it's not nearly as cold, and the residence time in that layer is not deep enough or cold enough to freeze it back into ice. And so it stays liquid, and it hits the ground and freezes on contact, because the contact of the temperatures of the terrestrial objects are below freezing. So again, if you go back and you take that -10 to -20 degree range there, and you have no ice in there, those two lines diverge again, you're back to actually the same thing. You're going to get freezing rain there or freezing drizzle. This is an example. This is a real life example of what happened, I guess, in 2016. This is a sounding, and notice you've got the green line is the dew point. The red line is the temperature, and notice that in those lowest layers there, it is totally saturated. They're all the way up. They're right together. But you get into that -10 to -20, it's very dry. Okay, so we have no ice. There's no ice in there. Okay, temperatures are -4 Celsius, so they're in the 20s at the surface. So what we've learned is if there's no ice in that cloud, we're going to have either freezing rain or freezing drizzle, depending upon the amount of lift is in there. This is a case, if you remember it, it was freezing drizzle. It only measured a couple hundredths of an inch, but it hit during the snarling traffic, afternoon traffic, and created all kinds of gridlock. So it's very insignificant, only a few hundredths of an inch, but created huge impacts. So those are kind of the things that we have to look through in terms of forecasting this kind of stuff. So I'm done with that section. We'll turn it over to Steve and see if there's any questions on it. It did get into the weeds a bit, but hopefully that will give you some ideas of what to expect and some of the things that we go through, so that you understand when we're talking about some of these in area forecast discussion. So Steve, any questions?
Jeff, we do not have any questions. Just a couple quick comments. It is a very scientific, rigorous process. I mean, think about it. At the surface, you got cold air and warm air battling it out, and only a couple thousand feet high, you've got the possibility of that so-called warm nose changing any snowflakes down to rain, and then depending upon which side of the plateau that raindrop falls on, maybe it's freezing, maybe it's not. It is one of these reasons why we are looking to use that probabilistic messaging to better provide an indication of our expectations, especially considering the resolution issues here in the Ozarks. So you go just a few miles or a couple hundred feet higher or lower, and you're going to get a different type of precipitation at the ground.
All right, well, we'll continue. This is the last section, maybe another 10 minutes or so. This is going to be on snow squalls, and snow squalls have been around forever, I guess, meteorologically speaking, but the Weather Service is finally addressing them here in the lab. Well, we started with snow squall warnings last year, And so we're going to talk about what is a snow squall, the impacts that it has, and then how do we go about messaging them? How do we go about giving our partners the information they need? So far, I will say we have not done anything in terms of a snow squall warning here as of yet. So we'll see that. Okay, so basically these are the definitions and when we're going to issue. We're going to issue a snow squall warning when there is radar or satellite indication or reliable reports from DOTs, webcams, road network of snow squalls meeting or exceeding one of the following conditions. Visibility 1/4 mile or less in snow with sub-freezing ambient road temperatures, okay? Second one is plunging temperatures behind an Arctic front sufficient to produce flash freeze. So you have the combination of this wall of snow basically and rapidly cooling pavement temperatures and air temperatures. Now, if a winter storm warning or blizzard warning is in effect, a snow squall warning will not be issued. So the only time we're going to issue it is if there's like a winter weather advisory, or maybe there's nothing out, and then we'll be issuing it. And think of it, a snow squall warning is a short-term product. It's like our severe thunderstorm warning, except it's for a snow squall. We are going to coordinate this with the impacted emergency managers, and this is going to aid because we're going to get some real-time reports from this. It's going to add validity to our conditions and partners. So really, we've got, when we issue this, there's a high degree certainty that there's going to be impacts from it. So it's not just radar based or anything like this. We're going to be actually talking to the emergency managers and affected and looking at webcams and things like that. Okay, so here's a case study, a real life example. This was on December 9th of last year. A cold front swept across Iowa with falling temperatures and a narrow band of heavy snow reducing visibilities to 1/4 mile less for a brief period of time. This band was moving around 50 miles per hour, was moving to the, I believe, east-southeast, and impacted several interstates as it moved across eastern Iowa. So here's what we have. Keep in mind that I'm going to show the actual surface observations from Cedar Rapids where that red star is. But here you can see it. Again, I-80 runs from Des Moines to Davenport, and I can't remember what the, I don't know if it's 280 that goes up through Cedar Rapids or whatever. But it's impacting several interstates. This continues. This is at 1749Z, which is about 12:49 in the afternoon. So this is in the middle of the day. It zips through Cedar Rapids. Okay, continues, hits going right down I-80 there. It impacted, I think that's 280, I'm not sure. But it impacted those two, a very brief period of time, and then quickly moved off to the east, now going through Davenport. This is probably within an hour or two, 1950. So it goes across there. So let's look at, they issued a snow squall warning. This is what it looks like. There'll be a text version. And this is actually, I took it off their Twitter page. This was tweeted out. And it, talks about whiteout conditions and heavy blowing snow and dangerous life threatening, because what's happening is people are driving down the interstate, everything's fine, you're going 70 miles an hour, whatever the speed limit is, and all of a sudden you hit this squall of snow and your visibility just rapidly reduces to 1/4 mile. Now you may not get much snow with it, you may only get a ½ inch or an inch, but the rates are coming down at maybe an inch an hour or so. So here is the Cedar Rapids surface observing system. And notice as the snow squall hits around 12:30 p.m., it lasts approximately 1 p.m. So it only goes for a ½ hour at any one point, okay? If you look at the wind speeds at 10 a.m., the temperature, the ambient air temperature was 41 degrees, mild day, okay? But by noon, it's down to 28, and by 1 o'clock, it's down to 22. So in a few hours, it's dropped 20-some degrees. When the front came through with the snow squall, you see visibilities were 5 miles, 27 knots. It dropped quickly at 12:28 p.m. to 1.25 miles, then to 1/4 mile just 5 minutes after that, and then stayed that way for about a ½ hour until it cleared. But notice here, in this case, you had the strong winds, 32 knots, that's like 35, 37 miles an hour blowing. You have visibilities that are down to 1/4 mile or less, at times. You think of that driving down the interstate, and you've got your air temperatures going from around freezing to 22 degrees. So you've got the ingredients of flash freezing behind this. You've got the low visibilities. You have everything going that this is designed for. Here's a result of what happened. There was a 50-car pileup on I-80. This is just outside of Des Moines, Iowa. Again, this is in the middle of the day. This wasn't at rush hour. This was at 12:30 to 1 o'clock, depending on where you were, late morning in Des Moines. But it went down the whole section of I-80. Des Moines hit it. Then it went down, and Davenport got it as well. So it was short-lived, but way down the interstate. Now, these snow squall warnings, and maybe Steve can touch on this here in a little bit, they will go out across the WEA, I believe, so you will get notified by cell phones. I believe it's in effect this year, but Steve can clarify that for me here in a second. But excuse me. But so just keep that in mind. And obviously for MoDOT, this is big for the MoDOT people on here. Think about how you would react to this and things like this. I want to get into messaging. We're doing the pre-season messaging now. So we're introducing this, letting you know what it is, letting you know how we're going to go about doing things. Hopefully, from a meteorological standpoint, a forecaster standpoint, in that 1 to 3 days in advance, we can hopefully determine that the conditions are conducive for snow squalls. We won't know the exact areas. We won't know the intensity or maybe even the timing of it, but we will start mentioning that in the AFD, the area forecast discussion, or the hazardous weather outlook, or even possibly SIT reports and things like that. As the details become clear in that 1 to 24 hours in advance, we'll be able to start getting in on some timing and locations, briefings to state and local partners, obviously talking to MoDOT, KDOT, things like that, what may happen, what roads may be, and we'll be pushing this to social messaging as well. And then it's really much like the severe thunderstorm. You'll have a radar operator, you'll see it, they'll be coordinating with the emergency managers, they'll be looking at webcams, and they decide, yep, we've met the criteria, it's doing it, and they will issue then that snow squall warning for that particular area. So that's kind of the funnel approach that we have. Again, hopefully we can identify at least a day or two in advance that the possibility exists for that to occur. So I'm going to conclude here. I'll let Steve take it home, and we can address some of those snow squall issues if you have communicating, if he has any input on that, any additional input. Is Steve there, or did he drop off? He may have dropped.
Yeah,
okay.
Just trying to put my camera back on. Thank you, Jeff, for a terrific presentation, and for everybody's attendance during the last hour. Yeah, you heard a lot of new things. The ability to communicate emergency information is I think the most important thing to the Weather Service these days. We could put out a perfect forecast. We could put out a perfect warning. We could tell you within a high degree of certainty how many inches of snow or the amount of ice. But if people don't receive that information, understand it, they're not going to respond to it. So this presentation was largely geared towards all those products and services, and yeah, a little bit of a look behind the curtain that allows us to show you what goes into that forecast process. Now, the dissemination of that information, whether it be via NWSChat, the situation report, or in the case of the snow squall warning, as Jeff indicated, the potential for the snow squall warnings to go out on the wireless emergency alerts, similar to Amber Alerts, similar to tornado warnings. Well, these are the mechanisms by which we're going to deliver it not only to you, but to the people that you all serve as well, the parents of the school kids, the families that are listening to the evening news, the people that are getting information via social media. We would encourage you all, as we promote these things, please make use of the tools that you've got available to you. Please, if you see something that we put out on Facebook or on Twitter, please forward that information. This is the only way in which we're going to get the information out to the public as far as evolution of our services, the capabilities that are increasing. So again, please monitor our Facebook and our Twitter page, and feel free to just forward all, you know, take a snapshot out of it and forward it onto your account. I don't care. The important thing is, as partners, what I would really encourage you to do is forward that information out to the general public, and that is the way we become a weather-ready nation. At the bottom of the screen there, if you're not an ambassador already, this is your opportunity. This is your call to action. Please do a Google on Weather Ready Nation ambassadors. It's a very simple process. Just by working with the Weather Service, we're going to feed you some information, and hopefully that allows you to expand upon the services that you already provide to your followers, again, mainly via social media, but ultimately any means that you've got available to you.